Hi. Okay. So today we're moving into the next part of topic 9, which has to do with adding and subtracting mixed numbers. So just to refresh our memory, I know we've talked about this before. A mixed number is made up of a fraction and a whole number. So in this case of 2 and 3/4, 2 is the whole number and 3/4 is the fraction. So a mixed number, what it represents is something that's not a whole number. It falls between two whole numbers. So if I have the number 2 and 3/4, let me show you where that would fall in a number line. So if I set up my number line here, right, and I start with 0, and I'm going to end with 3, because if I think about 2 and 3/4, it falls between the whole number that's already here, which is 2, and the very next whole number that I would count with if I were to just be counting whole numbers. So after 2 in the sequence comes 3. So 2 and 3/4 falls between 2 and 3 on the number line. So now that I have my number line established, 0 to 3, I'm going to create markers for numbers 1 and number 2. Okay? Because my fraction here shows fourths, that indicates that each part of the number line between each whole number is split up into 4 equal parts. So I'm going to go ahead and show that now by splitting each part in half first, and then splitting those parts in half. So we have fourths. 1, 2, 3, 4 equal parts on the number line. I'm going to do the same thing over here for between 1 and 2. And I'm going to do the same thing over here for between 2 and 3. I know it's not perfect, sorry. Now I'm going to label them. So if this is 0/4, this would be 1/4. 2/4, which is the same thing. It's equivalent to 1/2. And as you can see, it's halfway through the line. So it is half, which is the same thing as 2/4. And here we have 3/4. The 1 we would call 4/4. I bet you remember doing this a while ago when we were still in school. If this is 4/4, we have 1 and 1/4, or same thing as 5/4. So you can see right here that mixed numbers and improper fractions are represented by the same points on number lines because they represent the same thing. They stand for the same amount. If this is 1 and 1/4, this is 1 and 2/4, also known as 1 and 1/2, also known as 6/4 as an improper fraction. Here we have 1 and 3/4, which is the same thing as 7/4. And 2 is represented by 8/4. And if you recall, this line also means to divide. So 8 divided by 4 is in fact 2. So the next one would be 9/4, but it's also known as 2 and 1/4, right? Because now we're into 2. So this is 2 and 1/4 of the line. Here we have 2 and 2/4 of the line, which is the same thing as 2 and 1/2, or 10/4. And over here we have 2 and 3/4, which is the same thing as 11/4. 3 would be known as 12/4. 12 divided by 4 is 3, right? So if this is the spot we're talking about here on this number line, 2 and 3/4, I'm going to show you why it's the same thing as 11/4 now. If I start here at 0 and I count each fourth, count with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we can say that 2 and 3/4 is equivalent. It is the same thing. It shows the same amount as 11/4. Okay. As we move further along in this topic here, lessons, today's lesson, tomorrow's lesson, Wednesday's lesson, we're going to be working with mixed numbers. We're also going to be working with converting improper fractions to mixed numbers. So I'm going to show you how we would do that. Okay? Here's an example. Let's say we have 12 fifths. Okay? What that essentially means is that we have a number line that's cut up into 5 equal parts between whole numbers, and we're representing 12 of them. So here's my number line. I'm going to start at 0, right? Now I'm going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Here we go. Here would be 1, because the number line is now split up into 1, 2, 3, 4, 5 equal parts, right? So this would be 1/5, 2/5, 3/5, 4/5. Number 1 is also known as 5/5, because if you recall, when the numerator and denominator are the same, it's equal to 1 whole. Then I'm going to do, but I'm not quite at 12 yet, so I have to keep going. So now I'm past the 1, 1, 2, 3, 4, 5, right? Here's my next whole number of 2. So now I have 6/5, 7/5, 8/5, 9/5. 2 is 10/5. Not quite there yet, so I have to keep going. 11/5, 12/5. Now, if I look at this number line, I'm going to keep creating fifths here. And this, if I think about the next whole number after 2, it would be 3, right? So 12/5 shows this. Here's 12/5. 12/5 is also the same thing as 2, right? And 11/5 would be 2 and 1/5. And 12/5 would be 2 and 2/5. So 12/5 is the same thing as 2 and 2/5. And if you think about it, we know that this line means to divide. If we do this, 12 divided by 5, right? 5 can fit into 12 2 whole times, because 5 times 2 is 10. And then to get from 10 to 12, it's 2 more. So the numerator of 2 represents the leftover to get from 10 to 12. So again, 5 fits into 12 2 whole times. 5 times 2 is 10, plus 2 more to get to 12. That's the remainder, if you remember from division. And the 5 is the number of equal parts, so that doesn't change. Okay? Let me show you some examples of what you're going to be seeing today now. This was just some background about why the mixed numbers equal the improper fractions and vice versa. Okay, so let's say that I used 1 3/6 of a cup of apple juice and 1 4/6 of a cup of orange juice to make a new kind of drink. Don't try this at home. This is totally made up. Okay? I want to know how much juice I have all together in my pitcher. So to figure out how much juice I have all together, I have to add up the amounts that I have for the apple juice and the orange juice. So the way that we do that is by adding first the whole numbers. So if I add the whole numbers first, right? 1 plus 1 equals 2. The next thing that I do is that I add the fractions. 3/6 plus 4/6 equals, well, I remember that the denominator does not change. And now I just have to add the numerators. 3 plus 4 is 7. Well, 7/6 is an improper fraction. So I have to convert that to a mixed number and then add it back to my whole number from the two ones being added together. So 7/6 as a mixed number would be 6 goes into 7 one whole time. 6 times 1 is 6, right? So one whole time. To get from 6 to 7, right? Because 6 times 1 is 6. To get to 7, I have to add one more. So my remainder essentially would be 1. So this is equal to the same thing as 1 and 1/6. Now let's say you have no idea how to do that. Could you draw a number line the same way that I just did and cut it into 6 equal parts and keep going until you got to 7/6? Absolutely. You'd have to start at 0 and draw a line. This would be 0/6. We'd have 1/6, 2/6, 3/6, 4/6, 5/6, 6/6. 6/6 is the same thing as one whole. So it's important that when you get to the same numerator and denominator, you know that it's one whole. Here we have 7/6. Well, it's the same thing as 1 plus one more sixth, right? 1 and 1/6 is this dot right here. Okay? Now we have to take this 2 and the 1 and 1/6 and add them together. I'm just going to erase this down here so that you can see. So I have 2 plus 1 and 1/6, and I do the same exact procedure. I add the whole numbers first. 2 plus 1 is 3, and then I'm left with 1/6 from this mixed number right here. So my total amount of juice would be 3 and 1/6. Mr. C and I are available today. Should you need any help, please reach out and let us know.